Today we'll talk about the Cyber Resilience Act, which comes from the EU, and I'm French, so I guess that's why I'm talking about it. No other reasons, but still, that's what we're talking about today. That in Yocto, how that plays together, and yeah, basically give you an idea of what might be coming. So a quick overview. We used to be named Adrien Embedded a long time ago. Now we're with Tekio. That was a rebranding maybe like 5-6 years ago, and we're part of AVNet. Our core expertise is embedded devices. So very low level, that's kind of our historical background, up to embedded application connectivity. And my name is Adrien. I'm a solution director in our Bellevue office, so just close by. It's pretty cool. I didn't have to travel. I was lucky enough. And basically helping our customer on the embedded device, so OEMs, device makers, build their solution, mostly based on Yocto, designing the overall architecture, and then helping them implement that. All right, so we're jumping directly into security. There's a small disclaimer. I am not a security engineer. That's my take on it. We have people who helped actually with some of the content. I'm personally not. That being said, if we look a bit at the map of what happened from a security standpoint in the US the last years, 2020, we had zero trust, and just like a very short summary. Zero trust architecture from NIST. Then we had some software lifecycle recommendation against from NIST. Then we have things for devices, an updated version for embedded devices of like, this is how you should do things, use secure boot, or they're not naming secure boots, but use these security mechanism and implement that on your device because it's important, security is important. And recently, so in 2024, things are definitely accelerating. We've seen the cybersecurity framework 2.0 from NIST. We have that cyber trust mark, which is going to be coming soon. So I don't know if they're going to put stickers on devices or what, but that's like what you get if you tick all the boxes that the FCC set for you. Right now it's in a draft, as a draft, but it's hopefully going to pass this year. And it's voluntary, so you don't have to, but it's nice. And then we have things around AI and a lot more that are also work in progress. One additional one that comes outside of the US is this one, the CRA. The big difference is that it is mandatory if you sell product in Europe. Product meaning software, hardware, both of those commercially. And mandatory being like there's a fee if you don't comply with the requirements. Now there's some time. The first version has been approved, we can say, in March, but the final version will come later this year, and it will be in effect in 2026 for vulnerability reporting, 2027 for the full scope of that law. If you ask, does that affect us if we're working on a Yocto project and we get like financing from the LF or not? I think not, reading it through. I hope not. Seriously, because it's a build tool, because for a lot of reasons. I'm not a lawyer. There's a lot of things I'm not. I'm not a security engineer. I'm not a lawyer, at least that. I really hope not, because that would make zero sense. And it seems like it's not going there, but we'll need confirmation. That being said, this is the CRA in a nutshell. It comes from one of their presentations. I thought that was cool. Gruyere on one side, a Gruyere with less holes on the other side. That's kind of the focus. And essentially, there's a big focus on that around vulnerabilities. So security, we've talked about that for a long time, lifecycle. Vulnerabilities is really the focus of that specific law. And there are two main axes in that. There's the product cybersecurity requirements. So secure design, doing a risk analysis, threat model, having identities for your devices, things of that nature. And there is the process for handling vulnerabilities. So monitoring them, reporting them, fixing them, and all things that go around that. Interestingly, one of the limit of that what I mentioned is that this should be done for 5 years, or the lifetime of the product, whichever is shorter, which I was surprised, but apparently if you create a medical device and it's out in the field for 15 years, you can only maintain it for 5 years, and that's okay. Sure, okay, I guess that's fine. And there are security standards. They did an evaluation, but the security standards do not cover fully that, so they did analysis of like, the inside analysis of what's covered, what's not by that law, a bit more later on. Okay, that being, oh yeah, I forgot I had one. Yes, it was a thing, right? So I think you heard about that. Maybe a lot, maybe just a little, but here's one. So your device might be at risk if you're making a device, or if you're a maintainer. Well, that's one of the dependency. That's a problem. So how do I know if I'm affected, I guess, is the first question. Well, the good thing is there are tools. It's fairly easy. It all starts with the SBOM, the software bill of material, which is basically, as you might know, all the packages, the dependency of, if we're talking Yocto, your Yocto image. So based on all the version, based on all the package and the patches, what's in there, and from there you can derive information. The main one that's also part of the explanation is SPDX. I don't know if there's a way that people, SPDX, no, people say it differently. SPDX, that's fine, yeah. Which is supported by Yocto. As far as I know, it's the version 2.2, which is used in Yocto. The 2.3 is the last one, and 3.0 is pretty exciting and coming soon because it has profiles around like the full supply chain, your build environment, how was it built. So we're talking about reproducibility and things of nature. That's a great tool for that. I know that Kate also had, well, multiple people had talked about SPDX and the impact of that. The result, or what it looks like, is something like this, where you have removing a ton of information, but essentially the package, the license that you have in there, which is also important for other reasons, but the license, the hash computed on the code and a recipe, the version, that's kind of the main information to know if you're affected or not by a vulnerability. And the way to get that is you just inherit, create SPDX, and then you get nice SBOM at the end in the SPDX format. The next one is, okay, that gives you your software bill of material. How do I manage vulnerabilities from there? That's definitely the output, the input, sorry, the software bill of material. CVE check is the tool that is included in Yocto to help you with that. Part of this full cycle when you manage vulnerability is to, one, know what's in there, and that's kind of that point in the middle. Two, to look at your image and to say, okay, do these actually apply? Because you're gonna get a bunch, let's say, of false positives that will not apply to your image. So you need to basically go through those, see if they apply, see how bad they apply your system or not. So essentially doing a manual assessment of that content, applying the patch that need to be applied, retesting your image, storing the archive, etc., etc. So that's kind of your whole cycle, and it's just like work that security engineers do, or just people who work on that, to actually get things done at the end. So CVE check is helping a lot. SPDX is part of that. Then there's still some manual work to do. To use it, pretty simple. It comes from CVE check from that specific BB class, so you can inherit it in your overall, for your overall image. You can run it on a specific recipe. So if that example here, if my mouse is visible here. Here we're running the tool specifically for the XAUTL package. Otherwise it will run for your full image and give you a full report of your complete image. What you can do after that is update individual recipes with different variables. So you have CVE product, which is used to indicate this is actually the name that is used in a NIST database to match the package with the one from the vulnerability database. So that's something you can use if it's not fully aligned. The CVE version is same for the version, otherwise it comes directly from your recipe, and then status is used to annotate that. And you have different statuses that you can use. That's a very short list of the statuses that are already present that you can customize in Yocto. So that's a quick example of from the configuration to the recipe or the configuration to the end for, oops, where's the mouse again? You have that file that lists all your statuses and what that matches to. For example, not applicable is just like ignored. For specific vulnerabilities, you can annotate them. You can add a reason in front of that, which is going to be passed. So that tag is going to be passed, that reason is going to be passed, and all of that is going to be in the result of your CVE. So if you look at that yellow, green, and cyan color, I know my colors, I guess. Is that right? Yes. You should find the same one on the CVE check report at the end. So basically tracked from your annotation to your CVE report, which is something you can store or use or share internally. Some of the limitation that I know of, and there are a lot of people who are smart here, so if there's anything that is not correct, let me know. I don't know everything. Some of the one that we saw is the configuration of the package are not used. That has a main impact for the kernel. So if you're, for example, not using Bluetooth, you're going to get vulnerabilities for all the Bluetooth stack, even though it doesn't apply to you. You can just ignore them, but that could be one area of improvement. The CV patches, when you patch things, have to be files because that's how CV check is going to be passing the CV and see if you patch them or not. And the third one is you kind of have to annotate that manually in the recipes. You can consolidate that actually in a single file, so that's not too bad. And you have one example, one base that you can use, which is this file in Yocto. All right, I'll close that quick parenthesis about CVEs. Beyond vulnerabilities, to me, being production ready means that you have something that is supported long-term, that is secure, that is scalable/reusable, lean, and then we talked about reproducible, of course, observables about the logging, being able to be updated, etc. What that means for XA utils, for example, is if you have a supported long-term version, one, you get a fix for it. It was mentioned, if it's not a supported version, you're not going to get a fix for it, and then you don't want to be in that position. Secure meaning you already mitigated it, so it's not going to be as bad of an impact on the overall product. The third one means you fix it once and you don't fix it for 3 products or 10, 20. If you have multiple ones, so you have a reusable platform. And if you build a lean image, so you don't include everything by default, but just the core of what you need and customize your kernel and everything, you don't even have it in the first place. So you don't even have that vulnerability. So you're good.
Thank you.
And the other 3 one, I'm not going to dive in. So same to echo what was said during the panel, look at the long-term versions, plan your software strategy, plan your upgrade so that you don't get caught off guard. And then of course there's like budget involved and making sure you can do it. But this is, unless that changes, this is like what you can do to make sure you're ahead of a curve and you're not lagging and you still have those patches available, patches, update features, and all of that. So monitoring the CVEs, doing regular updates, yearly kernel upgrade on a major version, and Yocto LTS, for example, in that case, every 2 years. What's the name of the next LTS, by the way? Yeah. Then we can look at the security part, and there are a lot of attack vectors. So when you're looking at the design of your product, you need to make sure it's designed properly. So authentication, making sure there's no debug tools. I'm not sure it's even designed, but making sure your image contains only what it needs to be, that it's overall secure. During the implementation, making sure that you check the inputs, all the best practices. And then people are going to try to attack that from a software standpoint and from a physical standpoint. So brute force, for example, on one side, or just like unscrewing your device and trying to hack into it. So there's a lot of things there. All of those are attack surface, attack points to your device. So it starts with your application, but you also have all your dependencies. You have everything on the side, all the other processes and services that run. You have all the other tools underneath that make your distribution, the drivers and everything you have running on the system, the kernel, of course, and even down to the bootloader. So in the end, you have a lot of attack surfaces. And then you have all of that in front. The question is like, what do you do with that? How do you even approach that, knowing you have so many possible vulnerabilities and a number of solutions in front of that? And the recommendation is you need to have a threat-driven approach. So for your product, what are the vulnerabilities? What is the risk? Where is that at? Where do you need to focus your energy? Because otherwise you could spend years implementing all of that and trying to make it work together. If there's no value, that's not where you should spend your time. And it's actually one of the requirements of the CRA to do a cybersecurity risk assessment that is the input for all the rest. They ask you to do a lot of things, I know. So how do you typically conduct it? You identify threats. So what are the different attack vectors? What's the impact? All the different attack surface that you have. And then you take a risk-based approach. So impact versus likelihood to make sure that you focus your energy on what's important. The output of that is, one, the security goals. So let's say you need to have secure boot, multi-authentication, different specific mechanism to patch those gaps that you might have in the system. And two, also the environment. The environment is, we assume it's always going to be running with like a firewall running. We assume that all the personnel is going to be trained to not do something. We don't want them to like open emails on a computer that is connected to it, and then like, what can you do? So that's both the mechanism you have to implement and the environment that your product is running in. Very briefly, it's a complete topic, but when you maintain all of that, it's a lot of work if you have end product and then you have end distribution, and this is of course simplified, but if you have one complete Yocto environment for each of these products, that's a whole lot of work to maintain. The recommendation is of course to have a platform distribution. So you build your platform based on the Yocto LTS, you build that in a modular way so that you can reuse that across, and then you provide the tools to use that efficiently, to be able to develop, to be able to test the different image, all of that. It could be, I don't know, 3 books. It's just, of course, this is where you need to go if you want to lower your security effort. The advantage of that is that you reuse your security baseline, because implementing those security mechanisms take typically a lot of time. You also reuse that threat analysis and all those insights and the documentation you get from that. And you can share the CV management process that we're going to see in a bit. So you can share all these different mechanism, tools, process, code across different products. So less effort. And we like to do less work. The only challenge with that is that it's not the final product. The platform is a part of it. So you reuse it across different products. The application here, the configuration is going to change. So you provide a baseline for security, but you want also flexibility for your users. So really what you're providing overall when you're doing platforming approach is defense in depth. Your platforms provide a set of mechanisms. Your product itself should also have the right approach to secure your device. It is really a baseline that you provide that needs to be adaptable in some way, and then documentation, which I know we all love to do, but this is something that will actually really have to do, because it's one of the requirements also of CRA to document that process, the mechanism, and all that. Which, let's be honest, is useful. It serves a number of purposes. Describing the threat, the environment, mitigation, we talked about that. Providing guidelines for the development, what mechanism is used, how to use that, when to use that. Enabling what we can call like a component-based analysis, where if you just like put together different components that are secure, it's easier to make your overall system secure. And you can use that also as a reference for vulnerability management, and it's very good. It's very helpful if you try to get your system certified, which people here know as well. A couple highlights, and we're getting towards the end of what I have to say. So a bit more concretely, and we try to distill a bit the message that's in the CRA. First, for the security side, you have that risk assessment. You have to ship your product without known vulnerabilities and be secure by default, which is a good recommendation. It might not be easy, but it's a good recommendation for sure. You have to be able to patch those vulnerabilities, and if possible, automatically, which I found was interesting. It's probably easier with Windows than with something else, but it's a great recommendation if you can do it. To protect confidentiality, integrity of the data, and to process only the data that you need to process. Not necessarily in that case, maybe for security reasons. No, you could argue it's for security reasons, but I think I personally appreciate that one. If they can, like, if we can avoid to collect and process all kind of data, that's great. The 5 is access control and monitoring and recording security events. That's a bit rarer today in the product that we see. But basically what they ask is, like, if you see events on, I'm taking a super simple example, but like sudo and request to, you're not going to have sudo on your devices, but if you see security events that are happening on your device, you need to be able to monitor and to log those and to be able to report that from your device. And the last one is a possibility to remove all user data, and that one is fine. For CVE and CVE management, monitoring, so that means having a list of your CVE in front of your SBOM, having both, because they both go together. Regularly testing, patching, of course, you need to patch those. Distribute those changes freely and without delay. And then communicate publicly when those are fixed. So in that case, it means once you ship your security fix saying we were affected by that vulnerability and we fixed it, but we were affected, so you have to talk about it. The full text is available here. It starts on page 297 to be interesting. It's a very long. I initially tried to read like from the beginning. I was like, "Where's this going?" It only starts on page 297. But here is a link if you want to have the full PDF with the details of the law, the pre-law. Now that I said all that, to me, it's really that security approach is the difference between business as usual, for example, with executils, and the second option, which is like chaos and late work night. It's a choice. Do you do the work before or consequences? The good news is if you're here, you're probably using Yocto. And Yocto can help you with all of that. It can only push the cursor so far. Like you have to be doing the first step, and you have also to do the last steps. But it lets you do a whole lot to tick all these boxes. So it just all starts with you. I'm just sorry there's that documentation requirement as well. I know it's not going to be fun. But that's it for today. Thank you so much, and I hope you enjoy the rest of the conference.